equations of straight lines. In this chapter, you will learn the following things. You will be able to differentiate equations of straight lines in various forms such as x equals to 0, y equals to 0, x equals to a, y equals to b. You will be learning angle of inclination, slope, x and y intercepts. You will be identifying and calculating the slope of x-axis, y-axis, the lines parallel to x-axis and y-axis. Then you will derive the formula for slope of any line other than parallel to x or y-axis with two different methods. One is angle of inclination and another is 2 points. Then you will understand what is the meaning of y is equals to mx+c, which is a very widely used equation of straight line. And then you will be applying all these things in proving various different types of sums, especially the collinearity of points. You can prove how the 3 points or more than 3 points are collinear. And then various applications, word problems based on all of the above topics. So let us begin this chapter. Now this is something basic that we have already done in previous classes. That is, how do we name the horizontal and vertical line? Suppose you have this horizontal line, blue colored highlighted line. If you take any number of points on this line, you will find that the y-coordinates of all these points is constant, that is -2 in this example. So in such type of lines, you can name it as y equals to -2. Similarly, if you have a vertical line like this, purple line, and if you take random points on this line, you take any point on this line, you will find that the x coordinate of all the points is fixed number, that is 3. So such lines can be named as x equals to 3. So naming horizontal or vertical line is very simple. You just have to identify which coordinate is constant. So in general, any line which is parallel to x-axis or which is a horizontal line, that can be given as y equals to constant. And any line which is parallel to y-axis, which is a vertical line, that can be named as x is equals to the constant number. Now based on this knowledge, can you guess the equation of x-axis? Yes, what will be the equation of x-axis? Y equals to 0. Yes, very good. The equation of x-axis is y equals to 0. And similarly, equation of y-axis. What will be the equation of y-axis? It has to be x is equals to some constant number, and on y-axis all the x coordinates are 0. So the equation is x equals to 0. So if it is asked you where you have to find the equation of x or y-axis, you will be writing y equals to 0 or x equals to 0. Now the important point of this chapter, gradient. You are familiar with this word gradient or slope. In mathematics, it is the word used for steepness. Whenever you climb a mountain or a hilly region, you say that this mountain is very steep or less steep. So gradient is the mathematical word used for steepness. The bigger the gradient, the steeper the slope of the line. The more is the slope of the line. Now in coordinate geometry, a line that slopes up, with line that goes up as we move from left to right, generally that line has a positive gradient, positive slope. And the line that goes down from left to right, as we move from left side to right side on the coordinate plane, if a line goes down, then it has a negative slope or negative gradient. We will see how do we find the gradient of these lines which is moving up or moving down. The slope of a line or the gradient, it is defined as the ratio of vertical change to horizontal change. With respect to horizontal change, how much vertical change is occurring, that is defined as the slope of a line. This ratio is also known as, in common words, we say this ratio as rise upon run. How much it is rising on a unit run of horizontal distance, that is called the slope of the line. Now to find the slope of a given line, let us say we are given on a Cartesian plane a line. You identify 2 points which has easily measurable coordinates. You can identify the coordinates of any 2 points from the line, and then you calculate how much it is changing in horizontal and vertical direction. So if you see these 2 points, what is the horizontal change between these 2 points? Horizontal change between these 2 points. And for this point it is 3. So total, if you count horizontal 1, 2, 3 and 4. So horizontal distance is 4 and vertical distance is 1, 2 and 3. So this way you count horizontal and vertical distance, which is 4 and 3. And then we apply in that formula rise upon run. It is rising 3 units and it is running 4 units horizontal. So the slope is 3 upon 4. We derive this formula. How do we find the slope? How do we find the rise? And how do we find the run? So let's say in the Cartesian plane, a line is given in which there are 2 points whose coordinates are x1, y1 and x2, y2. So as you can see, when you drop down to x-axis, the x1 and the x2 are the coordinates, and on y-axis, y1 and the y2 are the coordinates. So to calculate the gradient, you should know what is the vertical, that is rise, vertical distance, and that vertical distance, how much is the vertical distance in this example, in this diagram. So the vertical distance or the rise of this line is y2 minus y1, and similarly the horizontal distance, change in the horizontal distance or the run, that is x2 minus x1, and the ratio of rise over run will give you the slope of the line. So the formula is gradient of a line, which is generally symbolized with small m. So small m is equals to y2 minus y1 upon x2 minus x1. You can note down this formula for gradient of a line or a slope of a line. You will be given with two coordinates present on the line. So based on those two coordinates, you can find the difference of y coordinates divided by difference of x coordinate, that gives the slope of the line. Now suppose this line is making angle theta with the horizontal line towards positive direction. If you see here, the theta formed, this angle, if this is theta, means it is same as this angle, which is made with the positive direction of x-axis. So with respect to theta, which side is y2 minus y1 and which side is x2 minus x1? You may go back to one of the chapters known as trigonometry. With respect to theta, which side is y2 minus y1? Yes. So numerator is opposite side, and which side is x2 minus x1? So denominator is adjacent. So what can be the formula for slope? What is the ratio opposite upon adjacent known as? So tan theta is another formula for equation of line. When you are given with theta, which is the angle between line and positive direction of x-axis. Remember, this is important, positive direction of x-axis. If the angle is made with y-axis or with this side of x-axis, then you need to convert it to the positive side, and then you find tan theta, that will give you the slope of the line. Now you have to work on this situation. What will be the slope of x-axis or any line which is parallel to x-axis? You can have a rough diagram on your paper and calculate the slope of x-axis or any other horizontal line. Yes, angle will be 0. So theta is 0, so tan 0 is 0 value. So that way slope of any horizontal line will be 0. And what will be the slope of y-axis or any vertical line? Theta will be 90 degree. So the value of tan 90 degree is, so the slope of any vertical line which is exactly going up to down to up, the slope is either infinite or it is not defined. Now we find the equation of sloping lines. We have found the equation of horizontal and vertical lines. Now if the line is neither horizontal nor vertical, how can we get the equation of such lines? Let's say you are given with this line on a Cartesian plane. You identify few coordinates, few points, and check their coordinates. Here there are 3 points marked whose coordinates are -5, 0, -3, 2, and -1, 4. Now to name this or to find the equation of such line, we need to find a rule which connects the x and y coordinates for all the points on this line. So can you connect x and y coordinate with some relation, some formula, some mathematical operations? Okay, just check this. X coordinate -5, when you add 5, you get the y coordinate 0. Same way, x coordinate -3, when you add 5, you get y coordinate 2. And the same rule is applicable to the third point. So the rule for this given line is y coordinate equals to x coordinate plus 5. So the equation you can write as y is equals to x plus 5. This is one way to find the equation of any line which is other than parallel, horizontal or vertical line. Similarly, one more example. A line is given which is moving downwards when you go from left to right, and the relation between the coordinates of any point on the line is the sum of x and y coordinate is 4. So the equation is x plus y is equals to 4. Do you think this method is convenient to find the equation of any line, or it is more time consuming? So there is a formula, there is not a formula, there are many formulas for finding the equation. But before that, let us check what we have learned so far. What is the equation of line through F and G? You have to give the equation of line that is joining F and G, that means this line. And you have to give the equation of line which is joining A and B. So just based on what you have learned so far, give the answer. Very good. Y is equals to -10 for F and G. What about A and B? For A and B, you need to find the relation between x and y coordinates of both the points. So the equation becomes x plus y equals to 15. One more question. X minus y equals to 15 is the equation of line through which points? X plus y equals to 15 is for line AB. X minus 15 is the equation of line through which points? Yes, it is GH. GH, for H, x is 10 and y is -5. So minus y will be plus 5. So 10 plus 5, 15. And for G it will be 5 minus -10. So again it is 15. So it is the line passing through G and H. Now we derive some formulas which is easily applicable and convenient for calculations. Now there are three formulas which we are going to derive, and each of these three formulas will depend on the given information. The first one is we are given with 2 points. A straight line passing through two given points x1, y1 and x2, y2. You must be knowing two coordinates of 2 points on the line. Then you can use this formula to derive the equation. Now how to derive this equation? Let us take a random or a variable point on the same line. That is x comma y. X comma y can be anywhere, not in between. It can be on the lower side or upper side, anywhere. It is a variable point x comma y. Since all the 3 points lie on the same line, if you find the slope of x1, y1, x2, y2, that will be given as m is equals to y2 minus y1 upon x2 minus x1. Or if you find the slope between xy and x1, y1, the slope will be y minus y1 upon x minus x1. Since both these slopes are representing the same line, means they are equal. So if you equate these two slopes, you get an equation where x and y are variables, x1, y1 and x2, y2 are the given coordinates. So this is the equation of line when 2 points are given. It is known as 2-point form of equation of line. You can note down this formula: y minus y1 upon x minus x1 equals to y2 minus y1 upon x2 minus x1. Let us see how this formula is applicable in the question. The question will be: find the equation of line passing through 2, 3 and minus 1, 4. So the 2 points are given. That will be taken as x1, y1 and x2, y2. So 2, 3 is x1, y1 and minus 1, 4 will be x2, y2. So substituting these values of x1, y1, x2, y2 in the formula, we have y minus 3 upon x minus 2 equals to 4 minus 3 upon minus 1 minus 2. Simplifying and cross multiplying these numbers and writing the equation in the standard form of linear equation of two variable, our answer is x plus 3y minus 11 equals to 0. The slope of the line and 1 point given on the line. We have derived this 2-point form of equation of line, and in this 2-point form, the right hand side is the formula for slope. So instead of 2 points, when we are given slope directly, we can replace right hand side with m. Or if we cross multiply, y minus y1 is equals to m multiplied by x minus x1. This is the equation of a line when you are given with the slope of the line and 1 point on the line. You can note down all these formulas so that it is easy while solving the exercise. So write an equation of a line passing through 1 point 1, 3 and having the slope negative 5 by 4. The slope is directly given in the question, you just have to substitute in the formula. So y minus 3 is equals to minus 5 upon 4, that into x minus 1. Now simplify and write the equation in the general form. That will be your answer. Now the last derivation, the slope and intercept form. Intercept is when the line intersect x or y axis, that is called intercept. And here we will be talking about y-intercept only. The point at which the line intersects the y-axis is called y-intercept, and the point at which the line intersects x-axis is called x-intercept. But the formula that we are going to derive is only for y-intercept. And since that y-intercept lies on y-axis, its x-coordinate will be 0. So we assume the y-intercept in general form as 0, c. The slope is given, that is m, and if we use the slope point form of equation and replace this coordinate 0, c, we replace x1 as 0 and y1 as c, you get the equation of line in the form of slope and y-intercept. So this is the third and the final derivation of equation of line. So the question will be like this: write the equation of line having slope 3 and making the intercept of negative 2 on y-axis. So intercept on y-axis, that is c, represented as c. So put m equals to 3 and c equals to negative 2, and that gives your equation of the line. So this is the summary of the topics that we have done so far. The slope of a line, we derived slope of a line with two different methods: when 2 points are given and when the inclination angle theta is given. Angle theta is also known as inclination of the line. Then we derived three equations of line based on different given condition. The first one is when 2 points are given. The second one is 1 point and slope is given. And the third one is the slope and y-intercept is given. So this is a summary of what we have done so far. You can take a screenshot or you can note down all these formulas. Shall we start with few questions from 14a? Exercise 14a. Let's say question number 1. Find the slope of the line passing through the points A -2, 1 and B 3, negative 4. So 2 points are given, that means x1, y1 and x2, y2. These details are given. So slope is equals to, the formula is y2 minus y1 upon x2 minus x1. Vertical change upon horizontal change. So -4 minus 1 upon 3 minus minus 2. So minus 5 upon 5, that is negative 1. So this is the slope of the line passing through AB. Easy? Now instead of 2 points, one of the coordinate is a variable and then slope is given. See question number 2. If the slope of a line joining P, K, 3 and Q 8, negative 6 and the slope is given, m is equals to negative 3 upon 4, you have to find the value of K. So put in the same formula, m is equals to y2 minus y1 upon x2 minus x1. You get negative 3 upon 4 on left hand side equals to minus 6 minus 3 upon 8 minus K. Then you cross multiply and find the value of K by solving the equation. Negative 24 plus 3K equals to negative 9 into 4. So 3K equals to negative 36 plus 24, that is negative 12. Therefore K equals to negative 12 upon 3, that is negative 4. This is the answer. Understood question 1, question 2 and how to use equation of slope, formula for slope? Okay, can anyone say how can we solve question number 3? Without using distance formula, prove that the points A, B, C are collinear. If 3 points are on the same line, that means if you find the slope between AB or if you find the slope between BC, since the line is same means its steepness is same, its gradient is same, so slope of AB should be equal to slope of BC. So if you can prove this, you can prove that ABC are collinear. If at all you find that slope of AB and slope of BC is different, it means that A to B it is a line of some steepness, and then from B to C it is another line with a different steepness, different gradient. So you can see that if the slopes are not equal, they are not collinear. Question number 5. Equation of line parallel to x-axis, that is given as y is equals to some number. Now if the line is passing from negative 3, 2, that means x is negative 3 and y is 2. X, y are the coordinates. We require y is equals to some number. So y is equals to, what is the number in this case? So this is the answer. Question number 8. Find the equation of line whose gradient is given. Gradient means slope. So m is equals to root 3 and y-intercept is given. So that is c is equals to minus 2 upon 3. So what is the equation based on the given condition? Equation of line is, what is the formula? Keep that formula page open for when you solve the exercise, so that when you will see it multiple times it will be memorized. So y is equals to root 3x plus minus 2 upon 3. So you take LCM 3. So 3y equals to 3 root 3x minus 2. And if you write in the general form, 3 root 3x, 3y on other side, so minus 3y minus 2 equals to 0. Question number 4. It is given PQR are collinear. What is given? Points P, Q and R are collinear. So like question 3, slope of PQ will be equal to slope of QR. Now this is given condition. In question 3 you have to prove this condition. So slope of PQ, what will be slope of PQ? Minus 5 minus 1 upon 2 minus k, and the slope of QR minus 3 minus 5 upon k minus 2 minus 2. Are you getting? I have applied the formula y2 minus y1 upon x2 minus x1. Minus 6 upon 2 minus k equals to 2 upon k minus 4. Cross multiply. Minus 6k plus 24 equals to 4 minus 2k. Take all k terms on one side and constant on other side. So 20 equals to 4k, that gives k equals to 5. Yes, Namasvi?
Yes, sir, done.
Done. Question number 7, who was asking? Question number 7.